So you're talking about genotypes and
Yeah, did you have
Punnett
genotypes?
squares.
How to write them, how they are passed to offspring and Punnett squares.
Okay, so what is a genotype?
Description of an allele for a particular gene in an individual.
Mm-hmm. So let's say we were working with different hair color, like blonde hair or brown hair. What would be like the genotype that we would be working with? Like if we had to describe it.
Oh, so like color?
Mm-hmm. And so the colors that we'd be looking at would be like brown hair, blonde hair, etc., right?
Mm-hmm.
So what's the question you're asking again about genotypes?
So she said how to write them, read them, and how they are passed to offspring.
How to write,
And
read, and how they're passed.
yeah, to offspring. And then the Punnett squares.
Okay, have you guys done Punnett squares?
Yeah, but honestly, I don't know, it was like 3 weeks ago.
Is this the first bio you've taken in a while? Is this?
Yeah, well, my major isn't even bio, but it's part of the prereqs.
Mm-hmm. And what year are you in?
Second.
Second year? Okay. Okay, so how to write them. So I have like a little chart here that I have. So basically like genotype is our genes, right?
Mm-hmm.
So it's kind of what we're looking at. It's not going to be like the difference from phenotype. Phenotype is the physical attribute, like what we can see, right? So genotype is going to be different. It's going to be, we're actually going to write it as the dominant recessive letters.
Okay.
Does that make sense? So like if we were working with brown hair, we do like a big B and a little b. And so that would be, what would the like big and little, or which one's dominant, which one's recessive?
The dominant would be the capital,
Mm-hmm.
and then the recessive would be the smaller.
So if it was saying that a capital B meant you had brown hair, does this mean this person has brown hair?
Yeah.
Okay, yeah. So then this would be like our genotype. So it'd be this, it'd be the big, and then it'd be little and little. So it'd be dominant, but it's also like a carrier, so it can have a different hair color.
Okay.
And then dominant, so it would have brown hair, and then this would be like another factor. So maybe the capital letter for dominant might say has brown hair, but then a recessive lowercase letter might say does not have brown hair. Does that make sense? It's just to determine offspring.
Okay.
Just to determine like what hair color and what abilities they have. So that would be how we would write our genotypes. So if we were to look, here's a case. So if we were to look at flower color. We look at flower color, and we were given 2 different alleles, right? And so the alleles are always different, right? Or are they always the same?
No, they're different.
They're always different. So we would have 2 different factors. So we would have a capital letter, and this would be for like white flowers, right?
Uh-huh.
And then we have like a lowercase letter for pink. And this can vary. It depends on what you're working with. It's just like an example. Kind of understand genotype, phenotype, and how to write and read, and then also pass them on, right?
Mm-hmm.
So if we were to, we have 3 different outcomes with the alleles we have, right? We could have the capitals, we could have, or the dominant, we can have a dominant and a recessive. And then we can have a recessive, right?
Mm-hmm.
So what would these 2 mean together?
That it's white.
Mm-hmm. The flower color would be white, right?
Yeah.
And then what would this one mean?
That it's white. No, wait. Pink.
You think pink?
Yeah. Actually, white because it was in the front.
Oh, because it's in the front?
Yeah.
Could it also be white because this is dominant?
Yeah.
So like since it's, and sometimes how the letters are written to make it like even more recognizable that it is dominant is you write the R, the dominant like letter, and you write the recessive super tiny, so that you would see that whatever is the biggest would be what you get, would be dominant, and the capital letter
And then the bottom will be pink.
be pink. And why would it be pink and not white?
They're both recessive.
Mm-hmm. And so we know for our allele for recessive it'd be pink, right? Okay, so that is how we would write a genotype.
Okay.
So we have to be given the alleles first, right? So these are our alleles. Unless the assignment or the case says make up your own alleles, then you know obviously make your own. We always have to have your dominant and your recessive. So your dominant is like what you have most of, and then the recessive might have what you have less of, or yeah. So if you were dealing with like have you guys talked about sickle cell anemia? Like that? Yeah. So about the disease. So if you change the letters around, what if we had like has the disease but doesn't, or vice versa? This would be a pretty interesting thing to figure out your genotype of how your offspring would or wouldn't have sickle cell anemia, right? And so have you guys talked about carriers?
Yeah.
Yeah. So which one of these three would be a carrier for like a white? Which one would be a carrier for red flower color?
Right.
Pink, sorry.
Oh, okay.
I was using R's and I got confused. Yeah, pink.
The carrier would be this one.
Why is this one a carrier? I mean, you're right, but why?
Because the other one is the dominant one, so then the other one carries from it.
So if we were to
recessive would be isn't it most likely recessive would be the carrier?
So not necessarily that any recessive 2 letters would be a carrier,
Okay.
but this is specifically called a carrier because they're called genetic carriers. Basically, it says an individual is heterozygous. Sound?
Yeah, I was gonna ask you about that.
is that word kind of like?
Yeah, I remember, but I forgot.
So hetero we know is different, and zygous we're dealing with like the zygote. So we're dealing with what offspring we're going to be getting.
Okay.
So it's different offspring. So it's an individual. Individual is heterozygous for a genetic disorder. So let's just say, let's mark this out. Let's do something different so we can compare two. Yeah. Lactate. I think that's how you spell it. So lactate. So being able to consume dairy, right? So whether or not someone can produce or does not produce lactose. So if we say, so we have to write our alleles first, right? Because those are the most important. So a capital L would mean that my body does produce lactose, right? So I can drink milk and dairy, right? Produce lact, okay? And then our recessive, right, is going to be kind of like the opposite. It's going to be the other side of it. So if we say that the dominant is producing lactose, what would be the recessive?
Not basically the opposite.
So if we didn't produce lactose, then that would mean, yeah, exactly. Does not produce, right? So if we're looking at our offspring and we say, okay, I produce lactose, right? So I have a dominant recessive, but I also got or I have a dominant allele, but I also got the recessive from my dad. My dad doesn't produce lactose, right? So this is the kind of factor that I have, right? And then whoever else is like the mate in making the Punnett square, let's say they both are recessive because they are lactose intolerant completely, right? So if they're both recessive, that would mean that when that both of their parents, one of them had to be recessive or be a carrier, right? So I can produce lactose, but I'm a carrier. So that means that I'm fine. I can drink milk, it's not a problem. But when I decide to have children and the genes mix around and everything, my offspring could not be able to produce lactose. It's kind of confusing, but does it kind of make sense about genetic carriers? So then if we were to work on the Punnett square, because that's how we're going to find our genotype, right? And kind of see what we're working with. So I put mine on top, and then I would put partners in the bottom. So what would I put in the first box? Are you comfortable with Punnett squares, or are they still confusing?
A little bit.
Okay.
But I'm thinking on the first one you put capital L and then the this one.
Yeah, why do I put the capital, why would I put the capital first?
Because I was the dominant one.
And then what about the next box? Going this way.
Two of these.
Two of these? And then this one?
It would be. Oh wait, I don't know how to do it. I know how to start from here. Isn't it?
Yeah, so you know how we did like here to here?
Yeah.
It would just be here to that
Oh,
one.
okay. Oh yeah, because it goes down. Yeah, never mind. So it'd be that one and that one.
That's why I had us go across first, because
Okay.
the one this way is confusing sometimes. And then, so what's the second one? This one?
Yeah.
And then the last box?
That'd be 2.
So, looks like we're 50-50, right?
Mm-hmm.
So, half of the offspring does not produce lactate. So, cannot drink milk, cannot drink dairy, right?
Mm-hmm.
Half of the offspring
Could.
does, but is a carrier for not. So, if we had that, or if we had another one of these, it would be, or our outcomes would be different. But since it seems to be that we have 50-50, it's kind of like, well, it's either or, you know?
Yeah.
So
basically it goes like that and like that, right?
Yeah.
Like that, and then this one goes like that.
Yeah, so we can do another one really quick just to see. And then do this. If you want, you can fill this out. Oh, this one's a little, sorry.
This is capital. I'll do the little one.
Okay.
Like that?
So, okay, so it's pretty close. There's one of them that's gotta be flipped around though.
Okay.
Do you think you can figure which one? I like how you put the little dash underneath. So normally you wouldn't be able to write that like because your professor might get confused. But it's a good way to study so you kind of know which one's lowercase, which one's uppercase, so it's not confusing.
Is it this one? This one?
Oh, well, this one's a capital in the front, right?
Yeah.
Yeah, no, this one's fine.
Okay.
So that one's good. Why is that one?
I wouldn't know.
No, you're correct,
Yeah,
but
I
why?
wouldn't know why. Is it because that goes to that?
No, you have the right letters in. They're just in the wrong area. So you see how this one's capital, this one's dominant and recessive. This one's recessive and dominant. This would be incorrect. So you would get like marked down because you would get written like that. So you just flip it.
Oh, okay.
Yeah. So you were right with the which letters in which way. Just remembering that the dominant always goes first, even if it's like even if you have a recessive. That's like a good little point to make. Other than that, it was good. Okay, so it looks like we discussed how to write it, right? We discussed how to read a genotype, right? Because a genotype, like we said, is going to be the alleles put together, kind of what they mean. So we can answer what a specific genotype is based on the alleles that we're given, right?
Yeah.
So if you have this, you know exactly what this means. Obviously, produce lactate, carrier for not, right? So we can tweak that, right? And I'm pretty sure that we talked about how it's passed on to offspring, correct?
Yeah.
That if I have this and then my partner has that, this would be all different, and then you could see like whether or not it would produce or wouldn't. Yeah. Is that kind of clear? Questions about that? I know sometimes it can be confusing because you're like, why are we doing this? Why is it, kind of so confusing?
That's right.
Do you want me to erase this or do you want to?
No, I already read it.
Okay.
This, I never even heard of these words. Almost.
So we did talk about heterozygous earlier.
Yeah.
Right? So homozygosity. So we've actually just looked at all of it. I just didn't point it out so you didn't know the terms yet. So basically if we're looking at two dominant alleles, right? That would be homozygous like allele, right? So same allele for the gene. So the same, right? So if I have this and then my partner also has capital, then we are homozygous for the allele. right?
And then
Heterozygous would be different, right?
Mhm.
So it would be two different alleles for a gene,
Okay.
right? So it would be the dominant and the recessive. So same thing we just looked at, right? Heterozygous. I think the term that's confusing you is that it's heterozygosity,
Yeah.
and so you're like, what is the icity part?
Yeah.
I think it just means like as long as you kind of understand the term, I think it's talking about like in general, like what does it mean, kind of like a bigger outlook on what is heterozygous, what is homozygous, you know?
Okay.
Not like, okay, I understand the term, but how did you add like the icity part, you know what I mean? Or why is it?
Yeah.
Yeah. But if, I mean, yeah, so.
And then homo would be those two were capital L's?
Mm-hmm.
Okay.
Like this. Because you might get a question, I mean, when do you have your next exam? Wednesday. Oh, jeez, coming up. But like, you might have a question possibly that says, fill out the Punnett square for someone who's homozygous for. Now, how the question might be is it might say homozygous for a certain allele and someone who's heterozygous for another allele, right?
Mm-hmm.
So you have to remember, okay, same, different. But then that might mean that one person is homozygous and one person's hetero. So you just have to kind of remember that, okay, different, same, and then it might say each person, like each pair, because you're always working with two like sets of alleles.
Okay.
When it comes to the Punnett square, you're gonna look at one and then the other.
Okay.
And normally
I
one,
know.
yeah. That kind of.
Yeah, that makes it so much easier.
I know you're like, what is these words?
Yeah.
Anything else?
She said.
What's the whole like exam about? Do you have like is this kind of what it's about?
Yeah. That's right here.
Okay. And you're good with the recessive and dominant? We covered that.
Yeah,
pretty
we're good with
extensively. What about X-linked disorders?
I know that it's diseases that come from the X chromosome, I believe, and
Yeah.
boys are most likely to get it.
Yes. Well,
Something like that.
X-linked chromosomes. Well, what we do know is like, so obviously so we have female and we've got male, and we know that this is what?
Dominant. No, that's a homo.
Yeah, homozygous, and that would be
Yeah.
yeah. So it's important to remember that this is not homo because we don't have two X's, we have one X. So when we're looking, when we're doing the Punnett square, it's like it's gonna be 50-50 when we're trying to see the offspring. Have you guys seen the term hemizygous?
Not that I know.
Okay, I have that term here. I just wanted to explain it. So it's a genotype for an X-linked link in males. So I think that you were kind of correct in saying that males would have the X-linked disorders more.
Yeah.
Because they only have the one. They don't. How do I explain it? This is not a carrier,
Okay.
right? So before we talked about like this would be a carrier. This is not a carrier.
Okay.
The reason for that is they're two different letters. If they were the same letters, it'd be fine, but they're not. It's not a carrier.
Two different.
Yeah. So males cannot be a carrier, but females can be
Okay.
for the X-linked disorder. Even though these are both dominant, females can be a carrier. So that's why most of the males will have the X-linked disorders because they only have the disorder. They can't have it. They can't have the disorder and then not have it. So they have one X. So their X would only have the disorder. If that makes sense.
Mm-hmm.
Because then the Y is just there. But is it kind of? I think that I see what you mean. That yeah, the males would definitely have it.
Yeah, I remember her mentioning that. That's why.
And you were like, that's important.
Yeah. What's this?
But the X-linked disorders and the sex-linked genes and everything, they're completely different than what we just talked about
Yeah.
homos. Way different. Because you might get confused and think this is hetero or this is no, completely different factors.
Okay.
So it's good to know that before, and then jump on this and be like, okay, I understand this now. Or I can see the difference at least.
Okay, so they don't really. There's the DNA replication one that I need to know.